Okay, so in our last couple of videos, we took a look at the ERC4626 vault and how the accounting worked internally in the vault. Now, what we're going to do is we're just going to show how it works with a dummy strategy. So we have our token vault here that we previously implemented, and what we're going to do now is we're going to have a strategy. We're not going to do anything in the strategy, but just how a separate strategy contract would work in the context of the vault. Okay, so I'm going to do here is I'm just going to do a new address strategy. Okay, and what I will do is we're going to pass this into our constructor. So address underscore strategy, and then in our constructor, we will just say strategy equals underscore strategy. Here we go. So we'll pass the strategy contract. Say we wrote a strategy contract that loops our assets into a lending vault or something like that. We'll pass the address of that in, and it'll set as the strategy in here. Now, what we need to do is just take a look at something real quick here. So if you see when we implement the total assets here, and what it does is it returns the balance of this asset for this vault, okay? And if you look at total assets within ERC4626, so we go in here, we go total assets. There we are. So we see that we have implemented this function here, and this virtual function. We've overridden it here. And we've implemented it with our own logic, okay? But if you go back here and you notice we just do a search for this total assets, if you look at all these convert to shares, convert to assets, they all use total assets of the vault, okay, for its accounting logic there. So if you look at them there, every single one of them uses the total assets. And then if you get down and you look at your other preview stuff, what happens is that all backs onto it as well. So convert to assets will go for the convert assets, and then that's also using total assets. So what we really want is, what we're really saying here with our initial token vault without a strategy is that total assets is just anything that's in the vault itself. So the balance of address.this for the asset that we have, okay? Which makes sense because when users are interacting with the vault, they're giving assets over to the vault. So that's all the assets that are in its possession. But when we do a strategy and we pass it in, we're actually passing those tokens off to a different contract, and then that contract is passing them off then into another into some DeFi protocol. So we need to there needs to be layers of accounting done there to bring the full amount of assets under our control, including the yield as well. And we need to account for that. So instead of having total assets here, it's just a balance of this. What we're going to do is we're going to say assets. We'll say total assets in our strategy and total assets in our vault, because we're not going to have them in our vault. We're actually going to pass them off to a strategy, and then the strategy could possibly pass them off to a lending protocol or a liquidity pool or something like that, and then that will also have to account for the total assets back. But again, we're going to be writing the strategy as well, so in this context. So what I'm going to do is we're just going to go, we'll say uint 256, we're going to say total assets in strategy. It's going to be equal to asset balance of, I would say, strategy. Here we go. Then we're going to do something similar here. We're going to say uint 256. We're going to say total assets in vault. Asset balance of, and we do address this because we're calling it from the vault. And then what we're going to do, we're just going to comment this out, and we're just going to say return. I'm going to say total assets in strategy plus total assets in vault. So now what this is doing is, whatever our strategy that we're setting is, it's going to get the assets from them, from the strategy, and the assets of the vault. It's going to add them together, and it's going to return that. And as this total assets here is used in the ERC4626 accounting, everything should add up correctly. So all of our functions should work because, again, they're all using the total assets, which is total assets in both the strategy and the vault. So that's the way, that's what we're doing, and that's why we're implementing it there, okay? So I'd already written this earlier, and I just wanted to do it again on the video. But for the test, what I'll just show you, I've actually already gone ahead and done it in the test, but I'll explain what I've done now, okay? So within our test, if we switch over, I've added another user here. This is just to give us a third user that's going to deposit into the vault. And I've also created another account here, just called Aave Strategy, and it's that's really just for illustrative purposes. Again, it's just a wallet. It's just going to be a wallet address, or sorry, an account like this, but it's just one that we want to send assets to simulate another contract that we can send our strategy to. Okay. Again, we mint this Carol account, some tokens. And then the other thing that we've changed here is that we're in our token vault, because we changed our constructor here to say a strategy coming in. What we're saying now is pass the Aave strategy in, and that's where we're putting our strategy into this into the vault. Now, if I scroll down here, look at but the functions are all the same. Sorry, our tests are all the same here, so they're as they were, including with the dummy strategy. And now if we get down here, you see that I've written a couple of tests. So I've done with tokens being moved to the zero address, just to show you how that works. And then with tokens being moved to the strategy, just to show you how that works, okay? So with this one here, what we have is we have Bob deposit 100,000 tokens. We have Alice deposit 60,000 and Carol deposit 240,000 tokens, okay? This gives a total of 400,000 tokens, 400,000 assets deposited, and 400,000 shares withdrawn, or sorry 400,000 shares issued. Okay. Now, if we we directly transfer 50,000 of those tokens to the zero address, essentially burning them, so nobody has access to it, well, they'll see that we now have 350,000 tokens in the vault with 400,000 shares issued. So what happens there is when you divide this by this, that's how many tokens you're going to get back per share. So if somebody comes looking for 100,000 tokens, they should get back 87,500. So this is just a bit of accounting here, just to see how it works. If we do max withdraw, this is the max withdraw for Bob, max withdraw for Alice, and max withdraw for Carol. And what we'll do is just show you how this test works. We'll do forge, test, match test. That test should pass. There we go. So again, we're saying that if somebody simulates withdrawing 100,000 shares, they should only get back 87,500 token assets. And again, the reason for that is that we're actually burning 50,000 of the tokens here. So of course they can't get back the full range, okay, of what they've put in, because we have essentially burned it here, okay? And it's just to illustrate how the accounting works if if those tokens were to go without being accounted for in our total assets, okay? Because as you said, send it to the zero address, that's not being accounted for. It's literally, those tokens are literally gone in that context. If we scroll down here though, what we're doing, instead of sending to the zero address, we're sending to the Aave strategy. And what's happening then is when we send them to the Aave strategy, it is being accounted for. Because as we set up here, in our constructor, we have passed in Aave strategy, and the Aave strategy in here is in our strategy. Down here, we're getting the balance of it, and we're returning it. So when any calculations are done on the vault for the total assets, the strategy is actually being included here, whereas the zero address wasn't in the last test. So we go back over here, we look for Aave strategy, we go back down here. So we're transferring 50,000 over to that. Okay. So now we have 300,000 in one in the vault, or 350,000 in the vault, and 50,000 in the Aave one. Okay. So again, I should really assets in the vault are going to be 350,000, and we'll say total assets in Aave 50,000. So again, it still makes up 400,000 shares and 400,000 assets. So it should be one for one on this one. Copy this. You just go forge, test, match test. There we go. What we said here in the actual test is cert equal. We're doing down here, we're actually doing preview redeem. If I want to redeem 100,000 assets here, I should get 100,000 back, and that's exactly what's happening down here at the bottom, and that's why the test is passing. So that's just a quick way of showing you how it would work with a strategy. So again, just to reiterate there, in this test, we've essentially burnt the tokens, and the strategy or the contract no longer has access to them, and they're not accounted for whatsoever. So when somebody puts in 100,000, under the hood, using total assets, the accounting is working, and it's saying that you can only withdraw that many. Okay. And what we're doing here is we're saying we're accounting for both the vault and the Aave strategy where the tokens are living, and then the accounting is working again. Now, this is fine from an accounting point of view. I'm just going to make this video quick, and what we'll do in our next one is I'll show you how it would work in regards to the hooks. So we can also in our vault there is hooks in this implementation, the transmissions 11 one. We have before withdraw and after deposit, because at the end of the day, when people are going to if people are going to withdraw the tokens, they aren't actually in the vault, so they can't withdraw if the accounting is working correctly. So as we said, the accounting is going to work correctly as for how much they can withdraw, because it's taking into account the two contracts. But we need to interact from the vault with the strategy in order if somebody withdraws. So, for example, if we were to pass 350,000 tokens over to Aave, and Bob comes in looking for 100,000, there's only 50,000 in the vault, so he can't withdraw that. So what we're going to have to do is we're going to have a look at using these hooks. And so in Bob's case, if he has deposited 100,000 but there's only 50,000 left in it, we kind of need Bob to, before withdraw, we need this hook to hook into our strategy contract and withdraw the token so that there's enough for Bob there. So we'll do that next.